I will tell you the error code of the Fujitsu mini-split air conditioner. When the timer light blinks 3 times, the unit stops operating and completely shuts down. So, what does this error indicate and what causes it? Additionally, we will also explain the differences between 1 ton, 1.5 ton, 2 ton, and 2.5 ton units. Although the same error code appears across different models, the cause and troubleshooting methods vary depending on the unit's capacity and model. Right now, you can see that the unit is operating and the switching process has been completed. Both the indoor and outdoor units have switched on. The expansion valve is functioning properly and the compressor has also started and reached full operation. However, an error has now appeared and the unit is blinking 1, 2, 3. It's blinking 3 times. This means that both the indoor and outdoor units were working, but as soon as the error occurred, the unit stopped operating. The company says that this is a serial signal reverse error during operation. If this error appears in the 1-ton Fujitsu unit, one possible cause could be a sudden voltage fluctuation in your home's electricity supply. This fluctuation can trigger the error, and in some cases, it may be temporary. To resolve this, turn off the unit completely and check the electrical supply using a multimeter to ensure that the voltage is not too high or too low. If the voltage is unstable, this could be the reason for the error, and stabilizing it might fix the unit. However, if the error is permanent, meaning that after checking and confirming a stable electrical supply, the unit still shows 3 blinks, then there is a fault in either the indoor or outdoor unit. In such cases, you need to trace the fault to identify the exact problem and proceed with the necessary troubleshooting. We have now opened an indoor unit PCB, and this circuit board is in front of us. However, before proceeding with troubleshooting, the first step is to determine whether the fault is in the indoor unit or the outdoor unit. Since this is a 1-ton unit, its power supply flows from the indoor unit to the outdoor unit. Now, let's examine the relay on this PCB. I will show you exactly where the relay is located and also open it up to give you a clear view of how it looks. This relay is responsible for supplying power from the indoor unit to the outdoor unit. The relay functions through switching, so to diagnose the fault, you need to check whether the error appears before the relay switches or after the switching occurs. This will help in identifying whether the issue lies within the indoor PCB or if the problem originates from the outdoor unit. If the error appears before the relay switches, it means the fault is in the indoor unit, and repairing the indoor PCB is necessary. Now, let's discuss what could be wrong inside the indoor PCB and how to fix it. One of the critical components responsible for communication between the indoor and outdoor units is the communication IC. If there is a fault in the indoor PCB, this IC might be defective. To troubleshoot, check the communication IC using a multimeter to ensure it is receiving and sending signals properly. If the IC is faulty, replace it with a new one. After replacing the IC, the communication between the indoor and outdoor units will be restored and the error will be resolved. This step is crucial in ensuring that the indoor unit is functioning properly before further diagnosing the outdoor unit. Now let me explain another possible fault. If you have started the unit and the relay has switched, but the error appears afterward, it means the problem is in the outdoor unit. In this case, you need to inspect the outdoor unit to identify the exact issue. Now, let's discuss the possible faults in the outdoor unit. To diagnose the issue, we have already opened the outdoor PCB for inspection. However, before identifying the exact fault, the first step is to check whether the serial communication is functioning properly. Once you have verified the serial communication, move on to inspecting the outdoor PCB. The key components to check include the rectifiers. There are 2 rectifiers on the PCB, and you need to measure their voltage readings. On the AC input side, you should get 220 volts, while on the DC output side, the voltage should be between 210 volts to 230 volts. Both rectifiers should have similar voltage readings. If both rectifiers are working fine, the next step is to check the SMPS, switched mode power supply, and inspect the switching IC to ensure they are functioning properly. This process helps in identifying whether the power supply section is working correctly or if there is a fault in the switching circuit. Often, the SMPS, switched mode power supply, develops a fault where it works intermittently, sometimes functioning properly and other times failing. In the unit I showed you earlier, it initially ran but then shut down, which was due to an issue with the SMPS. After replacing it, the unit is now working fine. Next, you need to check the discharge resistor, which should have 5 volts. If it is receiving 5 volts, then it is functioning correctly. After that, inspect the recovery diode and test the IGBT, insulated gate bipolar transistor. Once these components have been checked, move on to testing the IPM, Intelligent Power Module, as it can also cause the unit to stop working after running for some time. If a fault like this occurs, the compressor also stops working. Although compressors do not fail quickly, if all components have been tested and the error still persists, you should check the compressor's resistance to ensure there are no leakages. By following this troubleshooting process and checking all these components, you will be able to determine where the fault is and what caused it. Once the necessary repairs are made, the unit should function properly again. Now we will explain what could be the reason when an error appears in a 1.5-ton, 2-ton, or 2.5-ton unit. As you can see here, there are 3 PCBs placed. This PCB is used in a 1.5-ton unit, and this one is used in a 2-ton unit. The first fault usually occurs due to fluctuations because the unit stops working while operating, which then triggers an error. This fault is temporary, so first, check the electrical supply. If the electricity is stable, then inspect the unit. There is a chance that after a fluctuation, a single blink appeared. In that case, turn off the unit for about 10 to 15 minutes. The reason for this is that capacitors store charge, and when the unit is turned off, the stored charge is discharged, which clears the unit's memory. When you turn the unit back on, there is a chance that it will start working normally. Now, if after following these steps the unit is still showing an error and not working properly, it means that a fault has developed in the unit after the fluctuation, which is now a permanent fault. Now take a look at the 1-ton unit. In this type of unit, electricity flows from the indoor unit to the outdoor unit, so the indoor unit needs to be checked more carefully. But in this case, the situation is different. Here, the supply first goes to the outdoor unit and then to the indoor unit. Therefore, it is necessary to check the wires running from the outdoor unit to the indoor unit. Make sure there are no loose connections or sparks. Often, during fluctuations, wires can get burned. That's why it's important to check their continuity and serial communication to ensure they are functioning properly. Now, let me tell you that when you are checking a 1.5-ton or 2-ton unit, you will see that there are 2 fuses inside. If these fuses develop a loose connection within their holders, they can cause sparking. That's why it is very important to check them properly to ensure that no fluctuations occur due to this issue. If these fuses are faulty, replace them, and your fault should be resolved. The next step is to check the rectifiers. The 2 centered pins should have 220 to 230 volts AC, while the 2 outer points should have 210 to 220 volts DC. Similarly, check the next rectifier. Its center 2 points should have 220-230 volts AC, and the 2 outer points should have 300-320 volts DC. In standby mode, when the unit is not functioning, the DC voltage should be around 310 to 320 volts. After this, check the safety components on the board. There are fuses installed for protection. One is 3.5 amps and the other is 15 amps. In comparison, the 1-ton unit does not have multiple fuses, only a single 15-amp fuse. If this fuse burns out, the unit will give 2 blinks as an error indication. Similarly, if there is any loose connection at these points, whether in the board or the wiring, it can cause issues. Even a minor loose connection can create problems, so it is very important to check these points thoroughly. Now, let's check the SMPS system. 1. Switching IC. This can be faulty, so it should be checked properly. 2nd, chopper transformer. This component might also be defective, so inspect it carefully. 3rd, IGBT. Check this component to ensure it's functioning correctly. 4th, fast recovery diode, D102. This diode is often faulty, but it may not always show as defective during testing. Replacing it usually resolves the issue, so it's a good step to take. 5. Discharging resistor. Check this resistor. It should have 5 volts across it. 6. Capacitor. There is a possibility that a capacitor could be faulty, but before checking the capacitor, first test the discharging resistor. After these steps, check the IPM, Intelligent Power Module. Ensure that all voltages are present, including positive, negative, and UVW terminals. Now, take a look at the 2.5-ton PCB. It comes in 2 different designs. One where the PCB is installed in a specific casing, and another with a different shape. This second type of PCB design is used in both 2.5-ton and 3-ton units. Apart from the design difference, both PCBs function the same way. The reason for the design variation is that the 2.5-ton unit is smaller, while the 3-ton unit is larger. Now let me explain how the 2.5-ton and 3-ton units operate. They use the same system, where electricity flows from the outdoor unit to the indoor unit. Because of this, it's crucial to check the communication wires and other electrical connections to ensure no wires are burnt or cut. Step 1. Checking power PCB and rectification. If the unit is still not working despite proper wiring, check the power PCB. Electricity flows through the power PCB, and goes straight into the rectification circuit. In rectification, look at these two specific points, red and black wires, which carry power to the active filter module. From the active filter module, the current passes through the reactor and then to the filter capacitors. Step 2. Checking voltages in the power circuit. First, check this point. It should have 220 volts AC. Once the power flows through, it should be rectified to 220 volts DC. As the current returns from the reactor, it should measure 320 volts DC in standby mode. When the unit is running, this voltage should increase up to 380 volts DC. If the voltage is higher than 380 volts, then the filters or capacitors are faulty and need replacement. Step 3. Checking the control PCB and SMPS circuit. The control PCB follows the same working principle. Check the chopper transformer and SMPS circuit to ensure they are functioning correctly. Inspect the switching IC for any faults. Check the capacitors and ensure that 5 volts is present in the system. Step 4. Testing the IPM and active filter module. The IPM, Intelligent Power Module, testing process is the same as before. However, the active filter module requires more attention. If all other components are functional, but the system is still not working, focus on the active filter module. Check it carefully and replace it if needed. Following these steps should resolve the fault and get the system running again. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.